So we're on 1-5 day 2 today. Same thing as yesterday. We're graphing, but we're now being accurate. Whereas yesterday was just the type of graph and its location of its vertex, today is actually graphing every point accurately on that graph. Okay, that's what will be expected on your quiz tomorrow, is that you can graph them accurately. Yesterday you did y equals mx plus b accurately. You graphed every point accurately. That was the goal. And you got the vertex of the absolute value and the quadratics accurate. Okay, we're going to start with graphing some of these graphs down here in our notes. Okay, so actually, yeah, you know what, let's use these two right here. I want to graph these two. So this is off our example side. I know you already graphed these, but we're going to graph them accurately. So in your note page, on your note page, this is made so you can actually write your notes over here and reference your graphs. On your note page, I'm going to graph number 25 on one of these grids, and I'm going to graph number 26. So right above one of these grids, I'm going to write out f of x for number 25. F of x equals, let's see, absolute value of x plus 1, all plus 3. Okay, and then number 26, the other one we'll graph is f of x equals the quantity x minus 2 quantity squared, all plus 1. Okay, so we're graphing an absolute value and a quadratic. Okay. I know you know how to do linear. So the first step in graphing these, if you need to write down steps, the first step is to locate the vertex. Okay, so for those of you that need steps to follow, step 1, locate vertex. You should know that by using the HK. So looking at this on number 25, tell your neighbor what H is and what K is. Come up with an ordered pair for your vertex. Okay, time's up. Volunteer. What's H? Hannah? Okay, hold on. Need your attention up here, please. Okay, let's go with 25. So what's H on number 25? Yeah.
Negative 1.
Okay, so what makes this 0?
K would be
Negative 1, and it's actually positive 3. Okay, so we won't flip the sign on this one. On this one. Okay, it's whatever makes this 0. That's our H. And then our K is here. So if I'm writing HK, negative 1 and positive 3, that tells me where my vertex is. So if I go to negative 1 and up 3, there we go. That was in yesterday's lesson. So got that. That is our vertex. What type of picture is this going to give us? It's going to give us a V. So the second thing you may want to do is know the picture. Okay? So is it a V? Is it a parabola? Is it a line? And if it's a line, you didn't actually have to find HK. Hopefully you just use y equals mx plus b if it's a line. Okay? So we know that this one's going to be a V shape. So it may help some of you to actually off to the side, write the vertex, your HK, write your V. You know it's a V. On this, there's a form that we talked about yesterday. Remember that form is y equals a times x minus h quantity squared plus k. Okay, that was for your parabola. And then on your absolute value, you used y equals a times the absolute value of x minus h plus k. So very similar forms. Okay, when you're looking at the absolute value equation, your a term it's like your slope. Okay, and there's actually a b term we can add in here later, and you multiply the two, and that becomes your slope. But for what we're doing here, your a is your slope, the thing right outside. So what's right outside here? 1. So really, when I say it's your slope, it's the slope of one of your legs. we know that this graph is opening upward because A is positive. If A was negative, it would be opening downward. But in what we're doing today and in this lesson, everything's positive, so they're always opening up. I don't think we have any negative graphs on here. Nope. Okay? And since A is 1, I rise 1, run 1, rise 1, run 1. Okay? Now it's very tough because I say A is our slope, but then some of you will go, well, that just means I keep going downward the whole way. Well, not really. From here, we reflect these points over what's called our axis of symmetry. Or for some of you, it's just easy enough to go, well, I'm just doing a negative 1 into the point and a slope a positive 1 out of the vertex. So slope negative 1 here, and once you get to the vertex, you slope out a positive 1. The graph has to be opening upward. So that A term really tells us how much we're rising and running coming out of the vertex. Now every point is accurate on there. That's how, it's that simple when you're dealing with your absolute value graphs. Okay? Yeah.
What's the equation called?
This is vertex form.
Okay.
Remember we talked about that yesterday a bit? So when you're dealing with a quadratic, we start the same way. We locate the vertex. So everyone find the vertex, plot it on your graph. Okay, volunteer to tell me the vertex. Lee? What's that?
2, 1.
Yeah, 2, 1. It's what makes this 0. That's the 2. In this case, 2. And then 1. Our H term is 2. Our K term is 1. The picture, what's this picture going to be? It's a parabola. It's a U shape. Is it opening up or down? Up. It's up because the A, remember vertex form for a quadratic is this here. The A term is positive, therefore it's opening upward. In fact, the A term is what? 1. Okay? But it's positive, it's opening upward. Okay, so our parabola is going to open up. We're going to go to 2, 1, and that is our vertex. Now here's the part where some of you don't know this. If you're here this summer, you may know it. Okay? We know that these are vertex form. We talked about that yesterday. But those of you who are here this summer, I showed you a shortcut on graphing parabolas rather than having to use a table of values. You can always use a table of values. If you don't know how to graph something, table of values is the best way. I mean, if you go with the table of values route, you could have done that for your absolute value as well. But let's say I want to use the table of values for my parabola. If I go the table of values route, I'm just saying, hey, this is x, this is y. I know my vertex. My vertex in this case is 2, 1. So I'm going to put my 2 in and my 1. That is my turning point. I know that. It's this point on my graph. So from there, everything's a mirror image. I could plug in points. I could put in another point, like what's right after 2? 3. I could put in 3. If I plug in 3, I get 3 minus 2 is 1. Square it. 1 plus 1, 2. This is 2. That means another point on here is 3, 2. Okay? And then I can plug in the next one. Like the next value is 4. And I put that in. I get 4 minus 2 is 2 squared. And subtract or add 1, 5. Okay. So I get 2, 5, or 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And there we've got it. Okay? And then what you guys remember hopefully from geometry or from algebra is that when you're graphing quadratics, that when you get one side of a quadratic, once you have one side, if you reflect those points over this line right here, this is called your axis of symmetry, and we'll study this in more detail later, but it's a line that runs right down the vertex. Those points just reflect over, so this point comes over here, and this point, which is 2 units away, reflects to there. And so you have the other half of the parabola. And notice it's not a V at the bottom. Make sure you, from your vertex, you go out and then up. That way it's rounded off. If you need to at the end, like, make that a U down there. Okay? Now you'll notice I stopped there. I didn't put arrows because I'm not quite done yet, but I'm going to go with, I've got my 3, 2. So really the other point here is a reflection of this. So this was 2, 3, so I'm going to go here. So that's 1, and this 2 goes there. And that's 4, so this is going to be 0, and 5 goes there. Okay? Everyone with me there? That's one way to do it. The other way is using patterns. Okay? And you can use patterns if you understand what A is. Here, A is 1. All right? So to use patterns, I'm going to use a different example. Or actually, let me use the same example. Just do it on one of these other graphs. Then we've got them compared here. So 26, I'm going to redo right down here, and I'm going to use patterns to graph it. And I think patterns are a lot faster. Start out the same way. You find HK, and you figure out what the picture is. So in this case, once again, HK doesn't change. It's 2, 1. My picture still is that. Okay, I plot HK at 2, 1. How many are with me? Okay, I know I'm talking a lot, but I'm almost done. Okay, using patterns. Who was here this summer? How many remember the patterns? No. We spent like a day on it. There wasn't even a day as part of the day. But on a pattern, really what you're doing is you are going from your vertex. Okay, from the vertex. Every time from the vertex. You are going over and up or down, depending upon if your parabola opens up or down. In this case, it's going to be up because our parabola opens up. You are going over and up. Okay? So here it is. I am going to go over 1. How much did I go up when I went over 1 here? I went up 1. And then, so over 1, up 1. And then on this one, I went over 2 and up how far?
4.
I went up 4. Okay, well, let's go over 2 and up 4. And in fact, I could have added a point here. I could have said, what if this was 5 in my table? And I could have plugged that into here and said 5 minus 2 is 3. And square it, I get 9. And add 1, I get 10. So from my vertex, I would have went over 3 and up to 10. Or over 3 and up how much?
9.
And what do you recognize about these numbers? Tyler?
If you square the over number, then you get the up number.
Good. If you square this, that's how much you go up or down. With one exception. You've got to multiply this by your A term every time. Now some of you go, we didn't multiply it by A in this one. Well, we did. We just didn't have to, right? Like what is A? 1. So when we multiply by 1, it stays the same. But if this was a 2 out here, we'd have to go over 3 and up 18. Or over 1 and up 2. Okay? Or over 2 and up, how far? 8. Okay? So this is kind of the same thing. Once you have one side, you could either do the same pattern on the other side, or you could just reflect the points. And you'll notice on this graph that I just did here, I stopped before I hit this line, where x equals 3. Everyone see that? If I'm going to cross that line, you'd be like your parents saying, hey, don't cross this line, dude. You're not going to like what happens. Dude. Okay? If I cross that line, I better be way accurate. I better cross it at that point. If I don't, I just made this graph inaccurate. So like some students get yippity-skippity about things. They're like, woohoo, I'm done. Yeah, man. finished. And their graph goes off into Neverland, and you're like, what in the world? Dude, that's not right. And cross 3 here, and doesn't cross x equals 4 there, and doesn't cross x equals 5 there. Hey, don't get so excited about being done that you just get yippity-skippity and you're, whew, it's all done. Okay? You've got to stop at that last point you calculated and put your arrow right above it. Otherwise, you better calculate another point. So like on this one, since I calculated another point, hey, be my guest, keep going. Draw your arrow there. Okay? If I didn't calculate it on this side, or I didn't put the point, then I better not cross the line. But hey, since I put that point up there and I calculate it, there we go, man. We're good. Okay? How many are with me? All right. How many think they get it? Okay, let's see if we've got it. Let's try a problem. Yeah, what's your question?
So for the up or down, we multiply it by a after we square it, right?
Correct. Yep. You up or down, you multiply by a after you square. And we're going to see that right here. I'm going to make up a problem. So we're going to go f of x equals 2 times x plus 3 squared minus 7. All right? I want you to graph it. Use patterns to graph it. Ready, go. All right. So we start out with our vertex. Our vertex, our h and our k. So h is what? -3. Okay? That's what makes this 0. K is? -7. Okay, so we got hk. So we're going to go -3, 1, 2, 3, 1, 2, 3, 4, 5, 6, and 7 right there. We got our vertex. How many got that far? Good. The picture is this. Oh, not that. There we go. That's a little better. How many got the picture? Very good. Okay, we start at our vertex. Remember, if we're going over, and in this case, we're going up. Okay? Now, some of you asked me, you're like, hey, are we always going back to the vertex? You're always going back to the vertex. So this is over and up. So I'm going over 1. And in this case, I'm going up 1 times a, which is 2. My a term's 2. So it's 1 times whatever a is. Remember, that's our pattern. Okay? Over 1, up 1 times a. Always from the vertex. Okay? So over 1, up 2. That brings me there. Over 2, up 4 times a, or 8. So over 2 and up 8, which brings me to, I believe, right there. Okay? Over 3, up 9 times 2, which is? 18. Dude, that doesn't fit. Well, no, right? Brings me to 11, I think. Yeah, I know, but that's okay. So the question would be, hey, McCoy, how many points do I need? And the answer is you need at least 5 points on your graph. Hey, I got 5 points, man. I need to connect those points. Now, this one would be very easy to make it look like a V. So if I were you, you better get that U shape down on the bottom first. Make sure that that is not a V. Okay, and then from there, extend, and right there, as long as you put your arrows on, you're good. So if I put my arrows there, I'm golden. If I don't put my arrows and I get all yeehaw with it, yippity skippity style, you just lost points after doing all that crazy work. Okay, so don't do this. We frown on that. All right. Any questions? How many think you got it? Okay, your assignment is the mixed side, 7 through 39. Notice I have edited the directions right here, the instructions. I crossed that part out because that confused a bunch of you yesterday. So mixed side, 7 through 39. Every graph has to be accurate this time around. Okay,